All
All
right.
right.
So
I'll introduce you. Welcome everybody to PyData Global. We're so excited for our speaker today, Shivay Lamba, and streamlining AI development and deployment with KitOps. So we're so excited. Thank you so much for your time and being here to pour into the PyData Global community. Um, Attendees, please feel free to use the chat over on the right side of your screen. There's also a Q&A section if you want to drop some questions in there to be answered at the end of the talk. Any questions we don't get to today, we can continue those discussions in the Discord channel. But right now, I'm handing over the floor, so it is all yours.
absolutely. So thank you so much, Tamara. It's wonderful to be back at PyData Global. I've had the opportunity to present at PyData Globals for the last 2 years, 2022, 2023, and now with 2024. So, of course, like today's topic that I'm going to be presenting is going to be a super relevant topic around how you can streamline your AI deployment and development, because of course we are living in a truly generative AI era where a lot of companies, a lot of individual developers are getting their first ever experience of using AI. Of course, more in the terms of generative AI and large language models. But today's session is also equally applicable to all of the different kind of AI models that have existed for last 10, 15, 20 years. So today's session is mostly around how you can make AI development faster and more efficient with the help of open source tooling like GitOps. Now, one of the biggest challenges that we see today in and that has pretty much existed in the landscape of AI for a long time is the idea of transforming the AI models from these experimental notebooks. So typically, you will see a lot of data scientists, machine learning engineers writing their models, which are cutting edge, and they do great things. For example, image detection, image classification, or doing things like toxicity detection inside of the text. Now, while these are great as proof of concept and they solve a great purpose, but productionizing these into deployable solutions that can actually go ahead and be used by the wider public remains a very big challenge. And we'll understand more in depth about that particular challenge and how we can actually solve that challenge with the help of open source tooling. So, another interesting fact is that 80% of the machine learning models never actually make it to production because of the complex model deployment procedures that exist today. And of course, a big reason of this is because of the fact that there is this huge disparity between the data science or the machine learning teams writing these models in these notebooks, but then there's no apparent way for the DevOps or the MLOps teams to understand how they can actually deploy them. And that's also because of the complexity of the machine learning ecosystem, which we'll cover shortly. So, if we understand what's the biggest challenge that we face today with machine learning packaging. So, if we understand that, for example, in a standard workload that might be in a software, right, we can very easily just package together the entire software with the system dependencies inside of a containerized environment, which then can be deployed to a container registry like Docker. And then you can very easily just pull that image and run it, execute it, make changes, then republish that image. So the versioning of your software with Docker and all these open source container runtimes is very easy. But when it comes to machine learning, there is no standard way of packaging and versioning the different artifacts that is used to reproduce an AIML project. Because if you understand that an AIML project will have models, it will have datasets, it will have your notebook code, and some additional metadata, for example, the weights, biases, and if you see that we use different tools for managing all of that. Typically, the models will be written in Jupyter notebooks. Your datasets might exist inside of a S3 bucket or a data lake. Your code for the actual application might be in a GitHub repository, and all the metadata might be scattered across different storage environments. So when it comes to now, like let's say the data science team has written their code, and all of these different things are existing in different places. For a MLOps team or for a DevOps team, gathering all these resources is really difficult. And what makes it even more difficult is the fact that when we want to now push all of that ML code into into the pipeline. For example, if you're trying to, like, let's say, talk about a standard DevOps pipeline, that is, you write your code, you push it somewhere, and then you test the code, right? If you're trying to build a similar kind of a pipeline for machine learning, why is that not possible to do? Is because of the fact that if we inherently look at machine learning, it's because all of these different artifacts within a machine learning project exist in different places. And of course, we talk about versioning of different type of machine learning models, because a lot of times we are doing experimentation, tweaking around the weights of your deep learning model to see how that impacts your actual code, right? So all of those necessitate having a separate pipeline for deploying machine learning projects, because of the nature of the machine learning itself, which is a bit different than the standard software. And of course, where we need more individual expertise, and sometimes the size of the machine learning models can be huge, right? Like a simple large language model like a llama 3 is just 8 gigabytes in size. So we are dealing with different type of complexity and size of these models. So of course, these challenges lead organizations to adopt a separate MLOps pipeline. But of course, MLOps pipeline itself, like implementing it from scratch, can have a unique challenges of its own, because we want to ensure that how we are able to standardize all of the different data requirements. There will be specific requirements for security of these AI models, and of course, as we mentioned earlier, because of so many moving artifacts within a simple ML project. Like managing the life cycle of these models can be a bit tricky when you're trying to build a separate MLOps pipeline. Um, and of course, if we understand this more from a perspective of what are some of the challenges when we'll have the separation of the MLOps and DevOps pipeline. So of course, with MLOps, you will have distinct workflows for data scientists, for the DevOps teams, and MLOps, because data scientists are mostly focused on training the models and writing all of that inside of a Jupyter notebook, whereas the DevOps teams are more focused on the deployment. And there's no apparent way for them to be able to just pull a Jupyter notebook simply and go ahead and deploy it. And of course, when you're maintaining separate pipelines for DevOps and MLOps, that will a lot of times lead to duplicate efforts, because you're writing separate pipeline codes, and there has to be this manual handoff between the DevOps team and the MLOps team, because your code or the ML code that you're going to be writing might be used in some of your application level as well, for example, for making predictions. So that's some of the that's some of the difficulties or the challenges that we face. And of course, as we are having maintaining separate pipelines, this will increase or lead to additional technical depth, because we'll have difficulty in reproducing experiments. As we mentioned, that with AI, a lot of it has to do with writing experiments and trying out different model weights in order to make predictions, and how you are able to manage all of them will be a challenge. So that is where we'll first introduce now KitOps, and how KitOps actually helps us to solve that particular problem. So as we mentioned, that there is no standard for packaging and versioning of these artifacts which are needed to reproduce an AIML project. So that's the reason that KitOps was basically introduced to solve this right problem. So KitOps is an open source standard based packaging and versioning system for AIML projects. So KitOps basically takes the advantage of existing software standards, so that the tools and processes your DevOps or SRE teams use within your containerized applications can be again used with AIML projects as well. So KitOps as an open source project basically allows your ML teams or AI teams to package together the AI models, datasets, code, and metadata into what's called a model kit. And this model kit is essentially a version bundle that can be deployed to any OCI compliant registry, because the model kits use the OCI standard. So you can just deploy it to your typical Docker Hub or any other OCI compliant registry that you might use. So in this case, because it adopts that OCI compliant, right? It adopts the standards based packaging. We are not reinventing the wheel when it comes to utilizing some new tools altogether for deploying and safe versioning of your machine learning systems. So that's one of the key things that one of the key advantages of using something like GitOps. Now, of course, let's dive deeper into what are the basic building blocks of GitOps. So, at the heart of GitOps is ModelKit, as I mentioned, which is an OCI compliant packaging format. If we understand it more in depth, so whenever you version together any AI/ML project, it will package together all of the different modules, such as the machine learning model, the datasets, any configuration, and the dependencies that you might have. So primarily what you'll see are some terms such as the kit file. We'll come back to the kit file in a bit, but it will package together the model, which could be the serialized model itself and the model parameters, the code such as the notebook and any Python scripts, and of course additional documentation as well. So all of that, which are the building blocks of any AML project, and typically are being stored in different locations, all of them can come together and be served as one single OCI artifact, and can be accessed very easily through one simple registry, OCI compliant registry. And this makes it very easy for you to save and version your software or your AIML projects without having to increase complexity of having all of the different components being stored separately. Now, the next bit is the kit file, which is basically a YAML configuration file, which simplifies the sharing of all of the model, the datasets, and the code configuration when you define that inside of a YAML file. So this is how an example of a kit file will look like, where you define the YAML manifest file, you define your package name, and then you define the core components of the AIML project, such as the code, the datasets that you're using, the actual information about the model, and all of the additional artifacts that might be related to that particular model file. So this is a classic example of how you'll probably see that this is similar to any other type of YAML file that we typically work with. And this allows you to encapsulate all of the necessary information inside of your AIML project that will be required. So we'll have in-depth example of this when we dive into a dedicated example. And of course, the way to interact with GitOps, the best way to interact with GitOps is with the help of Git CLI. So the CLI allows you to basically run all of the different tools, and what you'll see is that it is a very similar experience with something like running a Docker pull, Docker, Docker build, and then Docker push, which is used to containerize an application software. As we will explore how you can package together your machine learning model file. So this is how a typical GitOps pipeline would look like. So with the help of the Git unpack, you can basically pull together the model kits that are deployed on any OCI compliant registry, and then you can run them locally. Now, if you're planning to build a sample model kit file yourself, so you just first of all create a kit file locally in your system, and then you use the kit pack to actually create the model kit. So this can be similar. You can think of this in a similar way, such as a Docker build, where you first of all create a Docker file, and then you use Docker build, which takes all of the different layers that are there in your Docker file, and creates the different layers, and finally creates the Docker image. And then you do a Docker push, so it pushes the image to an OCI compliant registry. So similarly, you use git push to help take that model kit that you have created from the kit file, and then you can deploy it to a remote registry. And of course, that's a OCI compliant registry. So let's actually look at a demo to understand that how we can take a look at a simple GitOps workflow file and see how that actually works. So let me go ahead and start to share my entire screen so that it's a bit easier for us to visualize all of that. So let me go ahead and share my entire screen. So in this case, hopefully you should be able to see an example. So I have a pre-recorded demo. So in this case, what I'm doing is that I have already installed KitOps, and let me go ahead and run this. Will probably just ensure that I can run this a bit quicker, so that so you'll see that first of all I run the Kit version. That's just for looking at the current version of Kit, and this is the CLI, the Kit CLI, which allows you to interact with Kit locally. Now, what I'm going to be doing is that I'll clear this and I'll do Kit login. So with Kit login, what it allows you to do is that it allows you to log into your specific OCI compliant registry where you want to actually log in. So in this case, you could use Kit login to log in into Docker Hub. You could log in into Zozu, which is another place for deploying the model kits. But of course, you can do that, and then you'll just put in your username and the password. And once you have put in the username and the password, then very easily you are logged into that OCI compliant registry. So in this case, it could be Docker Hub, it could be Azure. Now what we're doing is that we are basically going to pull using the kit unpack. We will pull a model kit file. So in this case, I'm going to be pulling the YOLO v10, which is one of the most popular machine learning models that is out there. So in this case, this is hosted on Zozo Hub, which is similar to Docker Hub, but for the model kit files. And as you can see that in this case, the model kit for YOLO will contain that specific things. So we just use the kit unpack Zozo Hub, and you see that the location of this particular model kit. So it's the YOLO v10 model kit file. And once we do the kit unpack, I will go ahead and actually, I'm in this case, I'm just creating a new file, because you see that, for me, like the kit file was already there. So let me just create a new repo. And then as soon as I start to do kit unpack and the specific kit file and the model kit, so it will unpack all of these different components that I have inside of my model kit. So you see that it unpacked the model, it unpacked the docs and the config, so all of the parts that were part of the model kit. And if I look at the list file, you can see that it contains the kit file, it contains the config.json, it contains the model.save tensors. So it has the main components of of my model kit, which are in this case the documentation and the actual model itself. Now, if I show you the kit file, so here is an example of this specific kit file that was used to generate the model kit. So in this case, you can see that I have the manifest file, I have the name of the actual package, and then the name of the model, and then the docs, because that's where I have the documentation about this particular model file. And so essentially the main use case that you see over here is that by basically taking the different components of an AIML project, I was able to basically take all of the different moving components which were typically stored in different locations, but package it all together inside of an OCI compliant registry. So if I now since I have downloaded this locally, I can also use that same kit file to package it together into a new model kit and deploy it to, like, let's say Docker Hub or any other OCI compliant registry for that matter. So for example, when I take a look at the list of if I run the command git list, so that basically shows me the list of all of the existing model kits that are stored locally. So these are all of the model kits that I have installed locally. So these you can see, the tag, the name. So some of them are from Docker Hub as well. So you can see docker.io. So these were published on Docker Hub. And the next bit that I'm doing is that, of course, you see that I've already created the kit file. So I need to have the kit file in order to package it together into the Docker, into the model kit. So now I use the kit pack command to take that kit file and then actually create the Docker, to create the model kit. So in this case, I'm just defining that particular value. And when I go ahead and do that, and I'll just quickly show you. So in this case, I'm just giving the path where I actually want to publish this. So in this case, since I'm using Zozu as my OCI registry, I give it a name and then I use the git pack command. with a tag that I want to give. And as you see that, it creates separate layers. So similar to how we have a Docker layers, right, in a Docker file or a Docker image, it creates the different layers. And then I can manually add it to an OCI compliant registry. So in this case, the example that I'm giving is with um, the Jozu, but you could also have a repository created inside of Docker Hub and publish it over there. But to publish it, because right now the model kit has been created locally, in order to publish it, you just use git push command, so that it will go ahead and publish this to the dedicated OCI registry. So in this case, it will be Jozu Hub, and when I push it, it will get pushed to Jozu Hub. And of course, as you see that, again, it does that layer by layer, very similar to how we do it with a Docker file. So of course, the main comparison, the reason I've been comparing between KitOps and something like a Docker file, is the fact that uh, uh, most of the DevOps teams typically use Docker files, and they typically deal with containerization with the help of Docker containers to containerize their workloads. So here it follows a very similar type of persona when it comes to handling the your model files inside of an AIML project. So you're not reinventing the wheel, and you can use the same set of standardized tools that you typically use in a containerized environment, and use that to deploy and make deployment of AI models and AI workloads very easy. So here what you're seeing is that we can also actually unpack only certain components by using the filter command or by the filter flag. So if you don't want to like, let's say, pull all of the different components of your file. For example, you just want to test, as a DevOps engineer, you just want to test the model file itself. You can just use the filter command to filter out the model. So that gives you a way to just install and unpack just the model and not the rest of the components. So you can do selective pull as well. So that's one of the reasons why we want to invest time into using something like KitOps, because it just helps you to standardize your AI ML deployment and use those same set of standardized tools, and without having to reinvent the wheel with by being focused on standardized tooling like being OCI compliant. So let me go ahead and start to share my screen again, my slide deck. So going forward again. So now let's also talk about like automating your machine learning life cycle with CI/CD. So of course, you can basically add KitOps as part of your CI/CD pipeline to automate the deployment of your AI models, and this could be triggered automatically or manually whenever, like, let's say there are changes that take place in your model. So by integrating KitOps as part of your CI/CD workflow, you could very easily just manage having different versions of your machine learning model, and manage this version control with the help of CI/CD. So an example of that is with the help of Dagger, which allows you to very easily productionize your CI/CD with the help of code. So in this case, like that, if you were to implement your automation of your AML workloads inside of CI/CD pipelines, then you can just install KitOps and Dagger.io, create the model kit with the kit file that I showed you, and then initialize the Dagger module, and then Daggerize your kit file, and basically define the pipeline functions, and then you can integrate this very easily inside of a GitHub action. So instead of your GitHub action, you'll define your actual Dagger components, and then you can very easily automate this deployment, so that you can have, like, for example, if you have changed any of your model configuration, model functions, then you can automate that with the help of Dagger, and inside of your GitHub action, and automatically just deploy that to your OCI compliant registry wherever you're deploying your main function to. So the main reason again why we are talking about all of that is specifically with the fact that when it comes to deployment of AI workloads, it's very important inherently to understand that AI deployments with CI, or working with AI and CI/CD, can be a fairly tricky, right? It can be fairly tricky because of the fact that AI pipelines are not as straightforward to work with. But by using something like KitOps, which allows you to package together the different components of your AI pipeline, you can leverage those same set of tools, and then just use them inside of a standard CI/CD pipeline, because we are thinking of AI workloads with the help of KitOps as any other artifact that you might have, like you might have in a standard software file. So that is why this deployment of AI workloads and versioning different type of AI models becomes very easy with the help of CI/CD as well. So you can integrate it with any type of CI/CD tool, whether it's GitHub Action, or you might be using GitLab Actions, whatever you might be using. It's very easy to integrate in that way. And of course, if you talk about like a MLOps workflow, so of course you can very easily leverage model kits for training and experimentation as well. You can package together your code, you can validate that, and then run inference directly with the help of model kits, because we are really just using model kits to define and package together your AI models, whether they are LLMs or simple models like MobileNet model. So all of that can be handled very easily with the help of model kits. And finally, like, of course, if you want to now go ahead and deploy a model kit, you can basically just create like an init container for your model kit, which will basically unpack the model reference from your model kit. And this is really useful, like if you're deploying your model kit to a Kubernetes container, or for Kubernetes deployment, or you can also use the Kit CLI container, which has the entire containerized CLI, which allows you to run any type of CLI command, which gives you a bit more flexibility to package together your model kits and then deploy them inside of a Kubernetes environment. But these are some of the resources, by the way. So you can check out KitOps. So by the way, like, it is completely open source as well. So you can take a look at the GitHub project. So it's still fairly new, but it is completely open source. So you can actually also contribute to it. So if you work with Golang, or of course in any other language, primarily of course, since it is designed for Python implementation, so you'll mostly use this with a Python based project, where it might be a notebook that you might have. But you can take a look at the documentation. There are a lot of great sample projects that you can look at, and there are a lot of bunch of DevOps, dev.to articles that you can take a look at to get started. And of course, now I'll be open to Q&A, but feel free to join the KitOps Discord community, and you can also connect with me on how to develop. But now I'll open up to questions.
Looks like we do have one question. Now I'll put it up here on the stage from Sam. Are you able to see that?
Yes. So
Can
the question by Sam is, can you combine Docker images with KitOps? So of course, I mean, when it comes to thinking of how KitOps works under the hood, so with KitOps, you are primarily packaging together machine learning workloads. But of course, and the way that the model kit has been designed is that it follows a similar interface like Docker images, but it's not the same architecture like a Docker image. But what you can very likely do is that you can take a model kit, deploy it inside of a containerized environment like on Kubernetes, and help it to interact very easily with a Docker container or a Docker image that might be running inside of a pod. So you can very easily communicate between the two. But of course, while you can think of both of them existing together inside of an OCI compliant registry, the basic structure of both of them is slightly different, because a Docker image, like, it's following a Docker file as the base, whereas kit a model kit follows the kit file. So of course both of them can be used to interact with each other, but it's not like that you can just merge together both of them.
fantastic. And we are out of time. Thank you so much for presenting today. Um, Attendees, please feel free to continue the conversation in the Discord channel. Um, I'm sure that our speaker would love to keep talking with you all. So thank you so much for attending. And this will be available for rewatch as soon as we end the session. Thank you.
Absolutely. Thank you so much. And I know like there is another question, if you don't mind like answering that one. So there is like this: can you handle large data sets with KitOps? So absolutely, no matter what model size or data set size that you might have, all of that can be packaged together and then it can be deployed. So there is no such big limitation as such. So just wanted to answer that.
Awesome. Fantastic. I'm glad we were able to fit that in. All right. I'm ending the session and drop your follow up questions into Discord. Thank you.
Thank you.